Okay, welcome to the notes on Chapter 1, Section 3 and 1, Section 4. We are right here today measuring segments and measuring angles. So let's go ahead and take a look at what we got. All right, we're going to measure segments and angles, and we're also going to classify some angles. Some of this will be review, so that'll be good. We'll recognize some things, and then some of it will be kind of new. So first we're going to talk about distance and length. Okay, what are distance and length? So very simply, I mean, we know what distance is. Distance or length is just the difference between 2 points, but it's positive, so we usually refer to it as like the absolute value of the difference between 2 points. Look at that handwriting. That is spectacular. Okay. So if we were to find the length, given this up here, we're going to find the length of each of the. So we're finding the length of each of these segments right here. Okay. I don't know why I just scribbled on the screen for no reason. All right. So AC from A to C, that's easy. The difference is -3, but because it's absolute value, we make it positive. So the length there is 3. Real easy. The difference between 2 and 3, or of DE is from 2 to 3, which is just 1. BD from -1 to 2, no problem, that's 3. And BC is just 1. Two segments with the same length are referred to as congruent. Okay, congruent is just a word. It means geometrically equal. All right, so geometrically equal, and the symbol for congruence is this right here. Okay, so it's a little squiggly guy with an equal sign underneath it. And for those that don't like my handwriting there, I magically made those pretty. All right, let's see what's next. So given AC is congruent to DE, if I tell you that AC equals 15, well, then what is DE? And if you said 15, you are on the right track. I don't know what is happening with my computer. Let's try that again. If AC is 15, then DE is also 15, no problem. Here we get a little bit more complicated. We're going to have to do some math now. If AC, again, they're congruent, which means equal. So if AC is 2x minus 3 and DE is 3x minus 7, well, then we can set them equal to each other. So we can say that 2x minus 3 equals 3x minus 7. Now this is important. You have to be able to solve equations. If I solve this equation, I subtract 2x from both sides, I add 7 to both sides, I get 4 equals x. Okay, if I went too fast for you there, you gotta let me know that's something that we need to work on with you. All right. Number 3, if AC is 4x plus 2 and DE is 6x minus 4, find x. And then this you got to be on the lookout for. Sometimes the directions will add a little thing at the end. And find the length of AC. So we're going to solve for x, and then we're going to plug it back in right here to find an actual length. So let's see, we got 4x plus 2 equals 6x minus 4. So then we get 6 on this side and 2x on that side, so x equals 3. But I'm not done. I'm going to take that and I'm going to plug it in right there. 4 times 3, so AC, which is what they asked me, is 4 times the x, which we know is 3, plus 2. So AC equals 14, and I need both of those to get the correct answer there. Segment addition postulate. If 3 points, A, B, and C, are collinear, and B is between them, then this part plus this part equals the whole thing. That should make a lot of sense if we think about that logically. Okay, this part right here plus this part right here equals the whole thing. Again, not real complicated, should make a lot of sense, and it's called the segment addition postulate. My suggestion with these problems is to label them as you go. So if the whole thing is 16, and AB, that's the part we don't know, BC is 5, well, then how much is left for AB? 9. Now, is AB, does it look bigger than BC? Yes. Sometimes in this class we'll get things they don't look like what they should be, and that's okay. All right, we're just going to go based on what the directions tell us. All right, let's do another one. On this one, on number 6, AB is 19. BC, we don't know, and AC is 23. Well, how much is left for BC? 23 minus 19 is 4. Let's do another one. Here we have AB is 3x, BC is 5x, and AC, the whole thing, is 8. Well, this plus this equals the whole thing. So I can say 3x plus 5x equals 8. So 8x equals 8. So x equals 1. Okay. And then lastly, we have an expression for each. So AB is 3 times x plus 7. BC is 2 times x minus 3. And AC is 50. All right, so here we're finding x and then we're finding AB. Okay, so let's say we have 3 times x plus 7 plus 2 times x minus 3 equals 50. Go ahead and pause the video for a second, see if you can work that problem on your own, then unpause the video and check your answer against mine. Go ahead and pause the video now. Okay, you've unpaused and you can see what I did. I distributed right here and right here. I combined like terms to get the orange section. I subtracted 15 from both sides to get the green, divided both sides by 5 to get the pink. X equals 7, and then I can't forget, I'm going to find AB. So I'm going to take that 7, okay, and I'm going to plug it back in. AB is 3 times 7 plus 7. Well, 7 plus 7 is 14, and 14 times 3 is 42. So AB equals 42. All right. If the equations are giving you trouble, you need to let me know in class so we can work on that. A midpoint. All right. Let's talk about what a midpoint is. A midpoint is the point that divides a segment into two equal parts. Okay. If M is the midpoint of AB, then the following relationships hold true. AM equals MB, 2 times AM equals AB, 1/2 times AB equals AM. I think for a lot of things like this, it makes way more sense when we draw it, okay? So it's not a bad idea to give yourself a drawing, something, whoopsie daisy, something to work from so we can see. So uh, here's here's B, and it says if M, that looks like about the middle, if M is the midpoint. So AM equals MB, midpoint means it cuts it in half. 2 times AM would equal the whole thing. 1/2 of the whole thing would equal one of the segments. Okay. Practice with midpoint. So if M is the midpoint, all right, again, I think it's useful sometimes here to work with a sketch or a drawing. So we have A, B, and then M in the middle. Okay, and it doesn't have to be perfect, but close enough. 9x minus 4. MB is 5x plus 20. Well, if M is the midpoint, then these two parts are equal. So I can set 9x minus 4 equal to 5x plus 20. Okay, subtract 5x from both sides and I get 4x. Add 4 to both sides and I get 24. And then x equals 6. All right, let's take a look at this one. Handwriting today is really bad. So now a little bit different here. AB, here's M, A, B. Now they're telling us AB, the whole thing, is 2x plus 10. And that MB, just this part right here, is 3x minus 4. Well, I want to know what AM is so that I can add those two together and set them equal to that. I do know what it is. It's also 3x minus 4. Okay? So, 3x, whoa, that was the worst 3 on earth. 3x minus 4 plus 3x minus 4 equals 2x plus 10. All right, so we add those. We combine like terms on one side. Then we're going to get letters on one side, numbers on the other. Sorry, the whole time I had that as 10, and it was 30, very clearly 30, so I fixed that. So I subtract 2x from both sides, I get 4x. I add 8 to both sides, and I get 38. And then I'm going to divide both sides by 4, and I get x equals 38 over 4, or 19 over 2. And you can leave it as a fraction. That is a-okay by me. Angles. All right, let's talk about angles. An angle is formed by two rays with the same endpoint that we call the vertex. Congruent angles are angles that have the same measure. Okay, we can name an angle sometime with a number like that, or we can name it as angle ACM. Sometimes we can just use one letter to name it, and that's if there's not other, a bunch of other letters around. If there's a bunch of other letters and intersections and rays and angles around, we want to use 3 letters to name an angle. Types of angles, this part's review, you guys know all this. Acute angles measure less than 90, right angles measure 90, obtuse angles measure more than 90 but less than 180, and a straight angle, which is a line, measures exactly 180 degrees. The angle addition postulate is just like the segment addition postulate, except it has to do with angles. So we're just saying that AOB, so from here to here, plus from here to here, equals the whole thing. Okay, not real complicated. So let's see that in action. If AOB is 45 and BOC is 60, what's the whole thing? Well, you just add them. It's just that easy. Okay, let's try another one. Erase that. If BOC is 50, and we don't know AOB, but the whole thing is 130, how much is left? Yep, 80. And then maybe the hardest kind of problem with this is when we have expressions, because we're going to have to solve. AOB is 6x plus 2. BOC is 4x minus 10. And then we're looking for AOC is 52, and we're looking for x. So I'm going to say that 6x plus 2 plus 4x minus 10 equals 52. Okay? And let's do this. Let's move that so it's right underneath the problem that we're looking at. All right, so that's right there. So now I'm going to combine like terms on one side of the equal sign. So that's 10x, and then minus 8 equals 52. 10x equals 60, so x equals 6. No problem. Easy peasy. An angle bisector, if BD bisects ABC, then what that means is that ABD, angle ABD, is congruent to angle DBC. It just cuts it into two equal parts. So if ABC is 46, then each one of these is 23. No problem. If ABC, the whole thing, were 52, like it is on number 10, and ABD is 2x minus 4, well, I know that if the whole thing is 52, then this one right here is 26, because that's half of 52. So then I can just say 2x minus 4 equals 26. Because it bisects them, I know these two are congruent. And if they're congruent, I have to split this 52 in half to get that 1. Then I can just say 2x equals 30, and x equals 15. Okay? And then, best for last, let's look at this one. ABC, so that's the whole thing, is 3x plus 12. So the whole thing is 3x plus 12. ABD is 2x plus 19. Find x and the measure of DBC. Well, if that's 2x plus 19, so is this. Okay? So I can say that 4x plus 38, all I've done is just add these two together, equals 3x plus 12. Okay? Then when I solve, I'm going to subtract x from both sides. I get x over here. I subtract 38 from both sides, and I get negative 26. If this were to ever happen to you on an assignment, you want to come get me right away, there's a mistake in here somewhere, and I believe it's right here on the 12. I think that should be 42, because we have a negative x. You can have a negative x, but it's going to give me a negative angle, and that's no good. But we solved for x correctly. We can't solve for DBC because we have a negative x. Let's just look at it. Just suppose with me, that this were 42. If this were 42, okay, then we would have 3x plus 42 equals 4x plus 38, and we would have x equals 4. Then, for me to solve for DBC, we did this earlier, all I would do is take that 4 and plug it in right here. 2 times 4 is 8, and 8 plus 19, DBC, 8 plus 19 is 27. So if this were 42 like it were supposed to be, that would be 27. Let's take a look at this one. This might be the hardest one here for us, okay? Let's go ahead and label what we have. XBA is 4x plus 3. ABD is 7x. XBC, that's the whole thing, 16x minus 1. And we want to solve for x, okay? Now, exclamation point. We're missing this angle, but this little mark right here tells us something. That little mark means the angles are congruent, okay? So what we are able to do, if the angles are congruent, is if this is 4x plus 3, then so is this. Okay, that little mark means the angles are congruent. So this is 4x plus 3, so is this. Now we can just add them all up. 4x plus 3 plus 7x plus 4x plus 3 equals 16x minus 1. Looks daunting. I promise it's not. Sometimes, by the way, this is a useful tool to draw a line where the equal sign is, and then I can just work my way down. So first I check if there's any like terms. Over here there's a 4x, 7x, and a 4x. That adds up to 15x plus 6 equals 16x minus 1 equals, okay? Then I want to get x's on one side, numbers on the other, subtract 15x from both sides, and I get x over here, add 1 to both sides, and I get 7. And that's it for the 1314 notes. Congratulations, you survived. See you next time.